Okay, now we look at alkanes. Alkanes are generally known as olefins. They are generally known as what? Olefins. And they have the general molecular formula of CnH2n. Now let's consider where N is the first member. If N is the first member, if N equal to 1, that's where 1 is the first member, rather. I have the formula is CnH2n, right? So if the first member is 1, you have C1, I have 2 times 1, I have CH2. But if I draw the structure of CH2, you can see what is on the board here. You discover that only 2 bonds is attached to carbon, but you have a single bond attached to the corresponding hydrogen. So if peradventure I decide to increase the bond by making it double bond, it still doesn't make any sense because 2 bonds cannot be attached to hydrogen. That is why we don't have anything as methane. Do you understand? That's why we don't have anything as what? Methane. Okay? Now we check for the next one. So this is wrong. Nothing as methane. Just like in alkane, we have methane. For the alkanes, we don't have methane. Okay? Now let's check for the second member. We have N equal to 2. We have C2. You can see the 2, right? 2 times, this is the formula. 2 times 2 is what? 4. So we have C2H4. Let's check out for the structure. C2H4, you could see that in this case now, you could see 4 bonds are surrounding carbon. 1, 2, 3, 4. I have 1, 2, 3, 4. And just a single bond attached to what? Hydrogen. What do you observe here? You discover that there is a double bond that is peculiar to this compound. So this compound being ethene and ethane, they won't have the same chemical property. Why? Because their functional groups are different. Do you understand? Okay. Then now for me to be able to get the next member, because alkane also belongs to homologous series, I just add my CH2. Instead of me using the general molecular formula, I just keep adding what? CH2, and I'll keep getting what? The next what? Member. So if I add CH2, since I've gotten the first member to be C2H4, so if I add CH2, of course, I should get the next member, C3. 2 plus 4 gives me what? It gives me 6. So the first step, I have to what? Draw my carbon atoms. 1, 2, 3. Right? And I will ensure that 4 bonds surround what? All the carbons. I could see my 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. Right? So because we're talking about alkenes, it means a double bond will be what? Present. So I can just remove one of these and put a double bond there. Right? So let's look at it very well. 1, 2, 3, 4. 4 bond is surrounding this carbon. 1, 2, 3. I'll put 1 bond here. 4 bond is attached to this carbon. 1, 2, 3, 4. So I just attach my hydrogen. I'll have H here, H, hydrogen, 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 and this by what? Hydrogen. If I was to name this compound, it is very important that when you're naming alkanes and alkynes, compounds that have double bonds, right? Double and triple bonds. When you're naming them, please always take note of the bond placement. Compounds that have double bond are said to be called what? Unsaturated compounds. While compounds that have single bond like the alkanes are called what? The saturated what? Compound. So in this case now, the double bond is at position 1, right? You can see the double bond. This is the bond position. We have 3 bond position here. We have, okay, this bond position 1. Okay, this bond position 2, right? Okay, just 2 bond position now. Now, because the bond position is at 1, if I want to name this compound, how many carbon is here? I have 1, 2, 3. So I say this is prop, right? So I will say this is prop 1N because the double bond is at position what? 1. So I must indicate this N. This N indicates that the functional group is a what? Double bond. Why this one you see here indicates that the functional group is at position 1. Is that clear? Okay. So to get the next member, I'll just add CH2. So if I have CH2 added to C3H6, it becomes C4H8, right? So we'll start by outlining the carbons. I have 1, 2, 3, 4. 4 carbons. And I make sure that 4 bonds are attached to each of the carbon. right? 1, 2, 1, 2, 3, 4. Okay. I can decide at this point to put the double bond here. Your choice. But whenever you have C4H8, maybe they just give you C4H8 that you write the formula, right? Always make sure that the double bond is at the first position. Do you understand? Except you're being asked in the contrary way. But always make sure that the first position is saves you stress. So in this case, I can see I have 1, 2, 3, 4, 4 bond attached to the carbon of this side. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we'll start attaching our hydrogen. So we can now count the hydrogens. The hydrogens definitely must what? Fit into what we have here. 1, 2, 3, 4, 5, 6, 7, 8. So if I want to name this compound, let me just clean this up so you could see very well. If I want to name this compound now, I have 1, 2, 3, 4. I have 4 what? Carbons. I'll say this is what? But, right? It becomes but. The functional group is at what? Is at the position 1, right? So it becomes but 1 in. If I peradventure shift this functional group to position 2, if I shift it to the position 2, for instance, it will no longer be, let me clean it very well. It will no longer be but 1 in. You can see it's at what? Position 2. So it will become what? But 2 in, right? If I shift it this way again, it will not be but 3 in. Because if I start counting from my right backward, I will not meet it at position 1. So you have to be very, very careful when you're answering questions involving this, okay? So let me just leave the structure at but 2 in. Then let's name this structure here. If you follow my previous illustration on alkane, like I told you that the first step you have to identify the what? The longest chain. The longest chain here is we have 1, 2, 3, 4, right? So the longest chain is butene. But in this case, not just butene, but 1N, right? So we'll say this is but 1N. But 1N is what? The longest what? Chain. Now, I started counting from this side. For alkanes, for unsaturated compound, you start counting from where you meet the functional group easier. For saturated compound, you start counting where you meet the substituent easier. But for unsaturated, that's ones that have double bonds and triple bonds. It's not like that. I will meet the functional group at what the first carbon compared to this side. So I will start counting. Every numbering will follow this way. So this will be my carbon 1. This will be my carbon 2, carbon 3. This will be my carbon what? 4. Do you understand? So in this case now, I have bromine, 2 bromine at carbon what? 3. So the name of this compound becomes 3, 3. You could see I'm using a comma to differentiate the two numbers. Then if I want to attach alphabet, I use what? Hyphen. 3, 3, di. Di means we have 2 of it, right? Di, bromo, boots. 1 in. That becomes the name of the structure. 3, 3, dibromo, but 1 in. So for the last one, this is the first one. Okay, this is the first one. This is the second one. You can pause the video and try this one in the comment section before you continue. Okay, now let me name this one. Looking at this one, the longest chain here is 1, 2, 3. You can also consider the longest chain to be 1, 2, 3. But I think I prefer taking this straight chain, okay? So if I start from this side or from this side, where will I meet this functional group easier? I'll meet it from this side, counting from my right. So this becomes my carbon 1, carbon 2, carbon 3. So the longest chain here is what? The longest chain is prop 1 in. Then the substituent, being a methyl group, is at what? Position 2. So this becomes 2 methyl prop 1 in. That becomes the name of this structure. We look at, for today, the last class of organic compound we refer to what? As the alkynes. The alkynes on the board, they have the general molecular formula CnH2n-2. They have triple bond as their functional group, it means that triple bond is what is peculiar to the what? To the alkyne organic compounds, okay? So now let's look at the nomenclature. They have the general formula CnH2n minus 2. So where n is 1, where n is 1, we have C1H2 into 1 minus 2. I have CH, 2 times 1 is 2, minus 2 is what? Is 0. So it makes no sense, right? And we can't have something like this. So where n is the second member, we have C2H2 minus 2. So this is C2, 2 times 2 is 4, minus 2. 2 times 2 is what? Hey, pause. I don't go make... Okay. So can we go back again? Now the last class of organic compound we're going to be looking at today is the alkyne. So they have the general molecular formula of CnH2n minus what? 2. They are characterized by a triple bond as their functional group. It means the alkyne, one thing that is peculiar to them is that they have the triple bond as their functional group. So let's take, for instance, where n is equal to 1, we have C1, 2 times 1, we have 2, minus 2. Everything we have is CH0. So it makes no sense, okay? So where n is equal to 2, we'll have something of this sort. We have C2, H2 into 2 minus 2. So this is C2, 2 times 2 is 4. 4 minus 2 is what? 2. So we have C2H2. This becomes the first member. This first member is possible because you could see here now, you could see the carbon to carbon attachment. You discover that 1, 2, 3, 4. 4 bond is attached to this carbon, right? You could see 1, 2, 3, 4 bond also attached to this carbon. So the moment 4 bond can be attached to carbon, it tells you that what? That particular organic compound is balanced, okay? So this one we call this compound. Remember, when we have 2 carbon, we use the word what? Et, right? So in this case, it becomes ethyne. It becomes ethyne. Now, we have about 1, 2, 3. We have 3 carbons, right? Okay. Now, I call this one ethyne without saying it's one ine, because this is just the first bond position. The first bond position. You don't have any other position again. But the moment you start naming this one, you could see I have 1, 2, 3. You can decide to 1, 2, 3. I call it prop. Right? Now the triple bond is at this position, is at position 1, right? I can decide to say this is prop 1 ine. You're still correct. You can still decide to call it propine. You're still correct because at this point is also position 1. If the triple bond is also not at this point is also position 1. So you can decide to call it propine or prop 1 ine. Either of them is correct, okay? So now we have some things to name on the board. We have 1, we have 2. Okay. So remember I told you when I was solving the previous examples, I told you the first step starts with identifying the longest chain. So the longest chain here we have 1, 2, 3, 4. The longest chain is the 4 carbon, right? And 4 is what? 1, 2, 3, 4. 4 is what? Boots. So we write boots. But the double bond is at which position? Let's start counting. This bond position 1. This bond position 2. If I start here, it's still bond position 1. This bond position 2. It means we'll meet the triple bond at what? The bond position was 2. So this is boots. 2 ine. This is the parent's name. Okay? Now, is there any substituent attached to it? Yes, of course, there is. You could see bromine attached in this compound. So, at which point is bromine attached? At which point is bromine attached? Let's start counting. Assuming we start from this side, okay? 1, 2. We say this is what? 1 bromo boots, 2 ine. You could see that I did not use comma or hyphen to separate anything here because between 2 alphabets, you don't use either comma to separate. You just write them the way they are. Okay? Now, you could pause the video and try this one. Oh my God, I believe this one might look somehow a bit, complicated, but you could still try it. Everything is possible. Okay, if you've done that, you can also comment in the comment section. Now, to be able to name this particular compound, you just use the illustration I gave previously. If I pour, or like this, like a pipe, for instance, it is a pipe, water will flow in this direction, right? It will flow like this. So the longest chain in this case, the longest chain is 1, 2, 3, 4, 5, 6. The fact that it is branch does not mean it is not a straight chain. Okay, so in this case, now the parent name is, we will start counting from here, or that's from the right side or from the left side. We'll meet the triple bond at what the left side is here. This bond 1, this bond 2. So we have 1, 1, 2, 3, 4, 5, 6. So this is the longest chain is hex, because it's 6 carbon. You could see it here, 6, right? Hex 2 ine. So is there a substituent in this compound? Just look at it very well. Have you seen it? There is a substituent here. So let's start counting. We won't use the same bond position to count for the substituents. We use the carbon position to count for the word substituent. So we have carbon 1, carbon 2, carbon 3, carbon 4, 5, and 6. So chlorine is at position 4. So to name this compound in full, I will say this is 4 chlorohex 2 ine. So this becomes the correct name for the compound. Okay, lastly, so in course of the video, if there's any part you aren't, really okay with, you couldn't understand properly, you could reach us to us on the comment section, okay? And if you also need further assistance in organic chemistry, prior to your JAMB exam, okay, so the link is provided in the comment section. You can reach out to us via our bio. Thank you.